Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Telerik. Create compelling app experiences across any screen with the Telerik platform. Telerik's end-to-end platform uniquely combines industry-leading UI tools with cloud services to simplify the entire app development cycle. Telerik offers everything .NET developers need to build quality apps faster. Try it free at telerik.com/platform. That's telerik.com/platform.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 485. In this episode, Scott talks with Matt Johnson about time.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today is all about time, and I'm talking with Matt Johnson, and you're up actually in a very nice studio. You're one of the few guests I've had on who has a nice studio set up. You borrowed one from Channel 9.
Yeah, I'm enjoying the environment here. They've got a great mic setup and good soundproofing, and it's on campus, so it's awesome.
Cool, I appreciate that. So, time. You work on Noda Time with
John Skeet.
John Skeet. I've had him on the show a number of times and I've talked to him a number of times. Mm-hmm. And would you describe Noda Time as being is it a vote of no confidence against system.datetime and the things around it, or is it just an improvement on it?
I don't think so. I think the general idea is that there are patterns for the domain of date and time. I like thinking about date and time as a domain problem, not necessarily just as data types. Sometimes they get mixed in with data types like int and boolean and so forth. But really, when you think about how a date relates to a time in a specific location, relates to an instantaneous point in time, those things do make up somewhat of a complex domain. And NodaTime models that domain exactly as the domain exists in the natural world, where system date time is more of some things put into the framework that help you interact with that, but you kind of have to bring that your own understanding of that model.
Okay, so it's about the clarity and the completeness of the model, which that completeness doesn't exist kind of out of the box.
It really doesn't. For example, one of the first things we see with DateTime in .NET is the system.datetime class, which is supposed to be, by design, a multi-purpose type. It is a date or a time and a date, or a time and a date in a specific location. Mm-hmm. And, if you get into software practices and single responsibility principles, there's several violations of that just in the nature of that design.
And do you think that this is a mistake? Is Noda Time something that should have been that the .NET team should have come up with? Or is this just a matter of completeness and, balancing being complete with
I think it's
shipping?
A little bit of both. There are some things in there that I would say is a mistake. There are things like the date time kind enumeration that make working with that class a little bit tricky. Some of those things were improved in the .NET framework with the date time offset type, but I think having the more completeness is exactly what the project's about. It's also about testability, being able to stub out things like the current moment in time, being able to interact naturally with other types of time zones. I'm not sure if you're aware, but there really are only two time zone data sets used in modern computing. One is from Microsoft and used with Time Zone Info and the Windows platform. And the other is from an open source project called the TZDB, which is now kind of curated by IANA, which is the same group that we get our IP addresses from.
Mm-hmm. Yeah, I had a lot of trouble with Clemens Vasters and I when we were working on DOS Blog somewhere around 2003. We ended up getting a time zone database and putting it into the registry because there was just nowhere to find this information, and we needed a database. Just as before JSON, and it was either XML files on disk or registry-based stuff. It was quite a mess.
Exactly. And that's kind of what Time Zone Info does today, is it pulls the data out of the registry and it relies on the Windows operating system to provide that data.
Mm-hmm. Why do you think it's about and I don't mean to keep picking on system.datetime, but it is 2015, and when the DateTime handling stuff, when when the system.datetime type and with the methods were done for .NET. This was 2002, Is there maturity? Was it 13 years that was required, or is this just a matter of what ships with .NET is fine for most people, but when you start getting into any kind of edge cases, you need to go and get a better domain?
Well, I think the original design had the constraints of that time period. Most people were designing for local computers on local desktops, and weren't really thinking about how they're going to interact with people on the other side of the world on a regular basis. We didn't have Internet of Things scenarios and cloud applications and all of these modern interconnected systems that we have today. And if we did, the people that were worried about time in those domains could kind of specialize in that. But I think nowadays, time is kind of introduced into almost every problem that has to do with business or anything that's non-trivial. Has some element of time to it. And I think having something built in would be nice. And there are some improvements happening in that area. I'm helping out a little bit with the core .NET Core team. We're doing some work on the system.datetime improvements. We've actually got some stuff going into a project on GitHub called CoreFX Lab. And a couple of things we're introducing, for example, as prototypes, would be a date type that's just a date. It's not a date and time. It's just a date because there are a lot of business cases for just a date.
Yeah, I know. I spend a lot of time just carrying date times around at midnight, and then I have to say, well, does this really mean midnight, or does this mean an actual date by
exactly.
itself? There's no unspecified time.
And if you consider that midnight doesn't exist on every local day, then your mind just kind of blows up. For example,
wait a second, what?
Yeah. So daylight saving time is a really interesting problem with date and time. Different parts of the world use daylight saving time or don't use daylight saving time. When they do use it, they use it with different starting times, different ending times, different times of day. And a really great example is Brazil. So when Brazil switches for daylight saving time, they do it right at the stroke of midnight. So the clocks there go from 11:59:59 to 1 o'clock a.m. So there is no midnight on the day of the spring forward transition. Which happens in November, by the way, not in March.
Wow, I just assumed that everyone did it at 2 a.m. on a Sunday.
Yeah, that's just the United States. And actually, that brings up another interesting point, is that when we do daylight saving time in the United States, we do it at 2 a.m., but we do it in 2 a.m. local time for each time zone separately. So it's like an accordion effect. It starts at the East Coast and works its way to the West Coast. But in Europe, they do it at 1 a.m. UTC. So the entire European Union that follows that set of rules transitions at the exact same moment. So if somebody ever asks you, like, how many hours are there between New York and LA? The answer is, well, it depends. Usually 3, but sometimes 2, sometimes 4. And that can't be said for, like, the 1 hour difference between London and Paris, for example.
It's such a rabbit hole to go down. There is still today, I use DOSBlog as the example because the two major projects that I've worked on that deal with DateTime was the banking system that I worked on before I went to work at Microsoft and DOSBlog. DOSBlog to this day is broken when we fall back because there's an hour there where it knows that it was the future for a minute and then suddenly it's not the future anymore. You know what I mean? Like it knew that somehow I have to look into the details, but basically it knew that we just backed up. So for an hour every year, there's a yellow screen of death on my blog, but it happens at 2 a.m. So I don't really sweat it.
Yeah. Well, it happens between the hour between 1 and 2. Right. And it happens twice, at least in the United States.
Yeah. But that has been a huge problem for me because everything else works. I just don't want to anger it because I know if I try to fix that bug, it's going to get even worse.
So one of the ways that happens in websites is by developers relying on time zone settings on the server, which in my view is an anti-pattern. You really should never call datetime.now from a web application or from a server application. And you really shouldn't rely on the time zone of the server to be anything in particular because you might pick up that server and move it. You might have an administrator go in and change it. And that's happened on some pretty large and notable websites, not just smaller projects.
Why? That's a really powerful thing. We should say that again. You're saying that if your application relies on the server being set on a certain time zone, you're doing it wrong.
Exactly. You really should rely only on the server's clock being synchronized, and make sure you follow best practices from an IT perspective to have those clocks synchronized.
Mm-hmm.
But the server should only ask the clock for its UTC time. If it's going to need a local time, it should know what time zone it needs to project that into, and that should come from the application domain. If you have a screen somewhere where the user picks their time zone, then that's what you should use.
So those understandings of time zones and what they want, those are offsets to UTC that you're storing in your own application's database.
Right. And when you do that, it's important to store the identifier of the time zone, not just the offset. I answer a lot of questions on Stack Overflow, actually. And I would say about a third of them are simply not understanding that a time zone is not the same as an offset. And the Pacific time zone that we're in here at Microsoft is a good example of that. Right now, we're at UTC -7 because daylight saving time is in effect. But most of the time, we're in UTC -8. So you can't just take one number and put it in the database and say that's the user's time zone.
But doesn't that mean that I also can't, what do I put in the database? Because there's PDT, Pacific Daylight Time, and then there's PST, Pacific Standard Time. If I put one of those in the database, it doesn't mean something.
Yeah, you really shouldn't put an abbreviation. There's too many that are ambiguous. Like Central Standard Time is often CST, but CST could also be China Standard Time or Cuba Standard Time.
Oh my!
Or there's 5 of them actually. It could be Australian Central Standard Time.
So do I need to? Is the GUID the unique ID a full-on English string?
Yeah, so that's when you get into the 2 different types of time zones. You have the ones coming from IANA that actually have standardized names. The Pacific time zone would be represented by a location identifier like America/Los Angeles. And that is an exact string that is an identifier, and you could put that in your database. If you're using .NET's time zone info with Windows time zones, you actually store the string Pacific Standard Time. But it's important to realize that doesn't just mean standard time. It really means Pacific time. And that particular string doesn't get localized. It doesn't get changed into different languages. It's just an identifier to represent that time zone.
Okay, so the string would be unique. It might say semantically, it might appear to say Pacific Standard Time, but it's really just an identifier that I would then pass into my library, Noda Time, and then it would tell me what the actual time was.
Exactly. As soon as you apply that time zone to a particular moment in time, a particular UTC moment, then you can determine whether it's Pacific or Daylight or Pacific Standard. And some of those IDs, especially on the Windows side, are really confusing. So I try to people not to read too much into it. Like there's one that's W.European Standard Time, and that is actually not Western European time. All of those zones are in Central European time. And then there's like 3 different versions of, is it Arab Standard Time, Arabic Standard Time, or Arabian Standard Time? There's 3 different spellings, and they're in 3 completely different parts of the world. So,
but they are in fact different.
They are different, and they are unique strings. And the point is just to not read too much into the IDs, other than just know that they represent an entry in the Windows registry.
Mm-hmm. There have been times in the past where I have had to be on calls and try to debug things, and the result was that, the Bangkok server's time zone got reset. And someone had to remote desktop into the server and check the control panel and switch time zones. Now this was 12 years ago, but I'm ashamed to say, I am very sure that there are people who are listening right now who would say that, oh yeah, we definitely know that the expense reporting server has to be on New York time or everything goes to heck.
Right. That's a smell of an older era, and I would say that if you have that smell, you should probably hit it face on. There is a best practice to say, well, servers should be set to UTC, and that happens in the cloud. Anything you run in Azure or in AWS is running under UTC, but you shouldn't rely on that. Really, you should be able to have your server set to anything you want to, because it's really just about what displays on the local clock.
Right. Because if you say datetime.utc now, no matter what time your PC is on, if it's appropriately synchronized, you will get UTC. Right?
Exactly. And if you use, if you need that local time, and there are scenarios where you need that local time, the best thing to do is use the datetime offset type. So you can say datetime offset.now, and instead of just getting the local time, you get the local time and you get its relation to UTC as that particular offset for that particular moment in time. So that gives you the best of both worlds. Like, for example, in IoT scenarios, if you are recording temperatures and you need to know that something is colder in the morning or hotter in the afternoon, that morning or afternoon is very dependent on that local time zone. So it makes sense to record the local time and its offset. If you don't record the offset, you can't get back to a specific moment in time, and that makes it really difficult to correlate logs and group things and all kinds of other wild stuff that happens if you don't know what time zone it's in.
What does that mean as I start persisting these things, putting them in databases or throwing them around in JSON? Does that mean that one date time is really multiple types? Like there's the date time and then there's the offset, which is a second column?
Yeah, well, there's some databases that support it naturally. Like SQL Server actually does have a date time offset type as a single field. Other databases have something called a time zone, they call it a timestamp with time zone, or timestamp TZ type. Not everything has that though, so sometimes you do have to store it in two fields. As far as JSON, JSON actually doesn't have a date format in its spec. Like XML, for example, requires that you use the ISO 8601 specification. Mm-hmm. JSON recommends you use the ISO 8601 specification, or actually the spec doesn't say anything about it at all, but that's the general best practice. Mm-hmm. But people have done interesting things in the past. In the past, things like data contract JSON serializer kind of invented their own format with some weird slashes. I think you have a blog post about that.
Yeah, I do.
We try to discourage people from using that particular format anymore.
There's a lot of I think when Rails came out, a lot of people started seeing times that would say a moment ago, mm-hmm. or an hour in the past. When did that start? And is that just an aesthetic choice, or?
It's actually a really good UX solution to the time zone problem. Thinking about, do I really want to relate to people at a specific moment in time and have to explain time zones to them? Or do I just want to let them have some sense of understanding how much duration has passed since I posted something on a website? And I encourage that you do that. There's a really great library for JavaScript that does this called moment.js. I'm a contributor on that library as well. And it's a free open source project. We're taking pull requests and interacting with the community. And it does have a feature for exactly that, for producing a string like 3 moments ago or last week or whatever.
It definitely adds a human touch. I've always impressed. It's such an easy thing to add, but getting time right and doing it in a human way adds a lot, mm-hmm. I think.
And when you do that, you really only have to be concerned with UTC. You don't have to worry about, well, what's the user's time zone and how does that relate to my time zone or any of that. If you know the UTC moment that something happened, you can tell how long ago that was, no matter where in the world you are.
Mm-hmm. Have you always been obsessed with time, or are you is this just a problem domain that you got into? Like, how did this start for you?
It's a really interesting story. So, originally I think I was kind of naive about time. Like, I think the vast majority of developers are. It's a really easy thing to be naive about because, as humans, we grow up learning in preschool about how the clocks work, and we kind of think we know this domain. And it's not until you get into computing that you realize there's more to it. But for me, it happened because I worked for a company that built timekeeping systems for employees, time and attendance systems. So an employee comes to work and they clock in and they clock out, which sounds like you don't have to deal with that with time too much until you consider businesses that stay open late in the evenings, might be open across a daylight saving time transition, or employees that are mobile, for example, a trucker that might clock in one time zone and clock out in another. So I started kind of going deep on the domain of time after running into those problems. And I kind of found the solutions widely applicable to many domains.
And that this wasn't like you were as a kid and you always had a watch, or there's no background story like that.
Well, I know my first basic program on a C64 at computer camp was a ticking clock.
See,
so there
you go. Now I don't feel so bad.
Yeah.
Now there is a blog post called "Common Anti-Patterns in DateTime for .NET Developers," mm-hmm. and I want to run through those. I think this is your blog.
Yeah, so that should be on codeofmat.com.
Yeah, Code of Matt. So when we talked about this, when measuring human activity, right, you always want to use UTC now for your offsets, right? You never do math with datetime.now.
Exactly. And if you do, .NET will get it wrong when you cross one of those daylight saving time transitions. Even though it's got that datetime kind local, it doesn't pay attention to it when it's adding and subtracting time.
Yep. I've totally had that happen. You store something, time goes back an hour, and then you suddenly get weird results, negative times or all sorts of things like that.
Right.
And then using DateTime.now for computational activity?
Right. And really, my recommendation there is don't use DateTime at all. .NET has this really great class called the stopwatch. It's under the system diagnostics namespace. Mm-hmm. And this exposes a different part of the hardware on your computer, which is more suited for measuring durations of things. Anything at the time you're profiling some code and saying, I need to know how long that took to run, you really don't want to introduce DateTime. Use a stopwatch. It's much more reliable.
Mm-hmm. And you mentioned clock drift. It seems like computers are really fast and do all sorts of amazing things, but they still fall out of time alignment.
Oh, yeah. They do actually a lot.
Why is that okay?
Well, because the way that drift happens, drift happens, but there's a bumper sticker for you. Mm-hmm. The way that happens is the oscillators on the computer can only be precise to a certain degree. And in most cases, it's about 10 milliseconds. So a real-time clock, when you call DateTime.now on a computer, is only precise to about 10 milliseconds. But that can change over time. It will go out of alignment. And that just kind of happens naturally. If you think about relativity and the whole idea that not everybody has the same perspective of time, computers are constantly trying to reconcile that. And a lot of it also just comes down to the quality of the actual components on the motherboard. So, there's routines in the operating system to watch for the clock drifting. And as it does, it makes corrections for it.
Mm-hmm. Your third anti-pattern basically says don't use the time zone class. Like, you just like system.timezone, go and do a search and replace right now. You should not be using it.
Yeah. So when you were looking at, or when you were asking about mistakes in the .NET framework, this was one of them. The time zone class was any time zone as long as it's yours. Like any color as long as it's black. And not only that, but it didn't actually work with the time zones the system had properly. So you may know that in 2007, the United States changed its daylight saving time rules. The time zone class isn't aware of that change. If you pull out a date before then, it'll still just use the current set of rules. Not only that, but it's actually gone. When you look at .NET Core, they decided not to move forward with it. And that's a good thing because pretty much anything the time zone class can do, the time zone info class can do better.
Okay, so time zone info is kind of time zone EX. It's the replacement.
Correct.
We should probably mark time zone obsolete.
Yeah, I'm not really sure what the reason they didn't do that, but I do know that it's been omitted from the .NET Core.
That's cool. It's great. I'm actually heartened that you are working on this stuff for helping them and consulting with them on the .NET Core.
Yeah, well, that's the great thing about open source, right?
Yeah.
So I do work for Microsoft, but I don't work for that team. And it's still great that they have the ability to accept input from me, and as if I was a member of the open source community on this work, which I am.
Mm-hmm. Now, what is the one about field validation?
So that's an interesting thing. So a lot of applications ask the user to enter a time. Like this comes up a lot during scheduling appointments. So you may say, well, what time is something going to happen? And you just accept that if it's a date and it's a time, and it fits into the class, that it's something that I can work with. But again, that goes back to daylight saving time. So if, like you said, in the United States, in the spring, we skip from 2 to 3. If I enter a time of 2:30, I probably should prop up on the UI, hey, this time isn't valid. And likewise, if I enter a time of 1:30 for the fall transition, I should probably say, hey, which did you mean? Because there's 2 1:30s on this particular date.
Yeah. When I tell my phone, like set an alarm for 7:30, it's really smart. Like if it's midnight when I do that, it assumes that it's 7:30 a.m., right? But if it's 6 in the evening, it asks. And to do that is hard. It requires willpower. It requires code and emotional willpower. I can imagine them having discussions about how we can make sure that this is right for the user. To do the same thing on a form on a web page would be quite challenging.
Well, do you remember early on in the history of I think it was in the iPhone, there was a problem with the clock going off at the wrong time of the day. It made the news. There were some big headlines about it, and people's clocks were wrong. So what that comes down to is there's this kind of mainstream understanding that you should always store UTC and just work with time zones at the very last minute. Well, that works great when you're recording time, when you're working with past or present. But when you're dealing with future, you can't do that because the relationship between time zone and UTC is up to the whim of the governments. We can change our minds. We can say, well, the DST is here right now, but next month it's going to be somewhere else. And that does happen all over the world. I mean, the U.S. is a little more pragmatic about giving notice, but in other parts of the world, about a dozen times a year or so, there are updates to the time zone rules that these different places follow. So you not only have to take into account that, hey, if I schedule something at 7 a.m. every day, it needs to run at 7 a.m. every day, not at 8 a.m., once the DST changes because I was recording UST or UTC. But
I remember that Windows 95 used to take big changes in Windows. I don't know how Windows changed itself, but I remember Windows 95, Windows 98 was constantly taking Windows update things and patches for new time zone information.
It's still doing that today.
Is it? Is Windows doing
Windows
that quietly?
Windows is still doing that today quietly, yes.
I don't see those showing up in Windows Update anymore, though. They're not quite in your face.
They're not in your face. They are out there as updates to the operating system. It's not a secret. You can go to Microsoft.com/time, and there's actually an RSS feed you can subscribe to that shows them. They do 2 cumulative updates a year that go to everybody. They're both towards the end of the year because that tends to be when these updates are centralized around. But there are hotfixes that come out all the time as necessary. And sometimes those hotfixes only get distributed to people that are directly affected by these time zones. And that in itself can be a problem. Like, Russia changed their base times last year. They got rid of DST and shifted everything down by an hour and opened up 2 new time zones. So this was a big deal, like ours 2007 big deal. And, those went out as hotfixes to the operating system, which meant that for a time, if you were scheduling an appointment with somebody in Russia, your time reflecting their time wasn't going to match up. So you might be an hour late or an hour early to their phone call. Now, since that's been pushed out into a cumulative update, we can hope that everybody has it. But there are some people that turn off all Windows updates, and those people are going to have their clocks out of sync.
What a mess. Yeah, I'm seeing here that they added Belarus Standard Time and changed Kaliningrad. That's amazing.
Yeah.
Kaliningrad, rather, excuse me. Okay, so then the final one, I'm looking at your blog post here, after field validation was reporting, and this blows my mind, assuming that all days have 24 hours.
Right.
That's if I can't count on that now, Matt, what can I count on?
You really can't. People like to aggregate things by day, and then they look at daily totals. Well, what happens when all of a sudden you see one day is significantly less or significantly more than another, and you think either you had a bad day or you were ultra successful, and that's not necessarily the case. It just may be that there were 23 hours on that day or 25 hours on that day.
And I would probably guess that I'm thinking about all the reports that I've written and reports that I may have even just written in Excel. I'm thinking that is an assumption that we have all made. And would that mean that we're grabbing extra hours? Like when it's really a 23-hour day, might we be accidentally borrowing data from, the edge and reaching into the next day?
Possibly, but usually not. Usually just your totals will be short that day or for that month or whatever period you're looking at. And
for
and
the
you might
25-hour days?
Yeah.
What about the 25-hour days? Are we missing an hour in there somewhere, perhaps?
Well, you're getting that 1 o'clock hour twice, right? Because of the spring forward, the fall back daylight saving time transition.
Well, that would cause problems with charts as well.
Oh, yeah.
You could see a spike at 1 o'clock on daylight savings time days.
Exactly. You'll see a big spike. And again, this comes down to how you group your data. So if you're grouping your data by the UTC day, you're not going to see this. But most businesses want data grouped by some time zone that they consider important for their business, some home time zone. And when you look at the local day and you do groupings, you will see spikes or dips for those things. You can level them out. You can average values across the other days and account for that to level out your graphs. But, of course, when you do that, you're artificially leveling it out because there really aren't 24 hours in every local day.
Now, you are actively working on your own kind of branch here called CoreFX Date and Time with some proposals for what you'd like to see happen in the .NET Core framework? Yeah,
so this is what I was talking about earlier. So this actually is being migrated over to CoreFX Lab underneath the GitHub/.NET repository set. And so CoreFX Lab has several things that are not guaranteed to go into the next version of .NET, but things that are being proposed. So originally I built this out on my own, in my own repository and invited a few other people to come help. And then when it reached a certain point, the .NET team said, sure, why don't you move this over and we can all start looking at it.
That's very cool. Congratulations.
Thanks.
And you also, I want to make sure that listeners hear about this, and I'm going to make sure to put this in the show notes. You have a 6+ hour long course called DateTime Fundamentals. I love that it's 6+ hours long, and it's just the fundamentals.
Yeah, I think I have an editing problem.
No. I think what it is that you're being extremely clear and precise, and you're including all the information that one would possibly need to handle this. If you're doing trading or medical software or anything, really, I mean, anything at all that touches a date time, that means that if you're not thinking about the things we've talked about on this podcast, you have bugs that you don't know you have.
Likely you do, and likely they're kind of bugs that are going to wake you up at 2:00 in the morning when you'd rather be sleeping.
It's funny how that works. They always seem to be 2:00 in the morning.
Yeah. The Pluralsight course is doing pretty well. I've gotten some really great feedback. And it is a little bit long, but I would encourage you to at least skim it and find the pieces that are relevant to your situation. I go deep on .NET and on JavaScript, but I also cover Java, PHP, Python, a little bit of Ruby, just to kind of give an overview of the ecosystem. Mm-hmm. And there are some differences in different languages and frameworks.
Cool. So I'm going to put your site and Noda Time and your 5 common daylight savings times, anti-patterns, and make sure that everyone checks out the Pluralsight course, all in the show notes. Thanks so much for chatting with me today.
Thanks a lot. It's been great.
This has been another episode of Hansel Minutes, and we'll see you again next week.